Let's prepare on the relation between the consistency limit of soil. So now we are going to see the various relations between the consistency limit of the soil. So the first one is the plasticity index, which is denoted by IP, which is equal to liquid limit minus plastic limit. So here if you see means the clay content increases, then the liquid limit also will be increasing. If the liquid limit increases, automatically the IP value will be increasing which is equal to liquid limit minus plastic limit. So the clay increases means what is actually clay? It is having a very lesser size particles than compared to other type of soil. So it is the least size particles among the soil type. So when the particle size decreases, automatically the IP will be increasing. For organic soil, both the liquid limit and plastic limit will be higher, so that the IP will be reduced. And then if the admixtures is added to the soil means like sodium base is added means the IP will be increasing, but sodium chloride is added means the IP will be decreasing. And the sand is known as the non-plastic soil if its liquid limit is less than 20%. So if it is having a lesser liquid limit means we call it as the non-plastic soil. The range of IP values is given here, so based on that we can find the plasticity of the soil. So if it is 0 or even if it is less than 0, that is negative, you should denote it as 0 only. So at that time we call that soil as non-plastic. Normally sand and gravel will be of these types, and if it is less than 7 it is low plastic, 7 to 17 it is medium plastic, and if it is greater than 17 it is highly plastic soil. And if silt is added to clay means what will be happening? Actually when comparing silt and clay, silt is having a greater size than clay. So when we are adding a greater particle size of soil to a clay means its IP will be automatically decreasing only. So this is also an important point here. And the next thing is the liquidity index. So the liquidity index is equal to the water content of the soil minus plastic limit by the IP. So IP is the plasticity index. So if you see here means the water content value will be varying with respect to the soil. So if the water content of the soil is normally the liquid limit means what will be happening? Liquid limit minus plastic limit by IP. So the liquid limit minus plastic limit is IP. We already know that. So IP by IP will become 1. So that the IL will be 1. So it means that the soil is in a liquid state. So when the water content is greater than liquid limit means the IL will be greater than 1. So which is denoting a very soft soil. If the W is equal to the plastic limit, then the formula will become as 0 because plastic limit minus plastic limit will become 0. So that it means the soil is very stiff soil. When the water content of the soil is equal to its shrinkage limit means the IL value will become negative value. So it means that the soil is a brittle nature soil. So you can see the diagrams here representing the shear strain and shear stress behavior of the soil with respect to this IL value. So when the IL value is less than 0, it is a brittle soil. So it acts like this. That is, it will be a brittling at a particular time. And if it is between 0 and 1 means it will be a regular curve. So if it is greater than or equal to 1 means it will be having a constant shear stress. Only the shear strain will be changing for that type of soil. So here the values ranging from 0 to 1 is given for IL and its respective behavior of the soil is also given here. So this is also related with IC value which we will be studying later. As these both are similar, I have written this both in a same table. So if you see IL, if it is greater than 1, it is a liquid state. If it is 0.75 to 1, it is very soft and it is plastic in nature. And if it is 0.75 to 0.5, it is a soft soil. 0.5 to 0.25, it is a medium stiff soil. And 0.25 to 0, it is a stiff soil. If it is less than 0, it is a semi-solid, hard and brittle in nature soil. So the same thing will be in a reverse case for the IC value from 1 to 0 in the reverse order. So here comes the IC which is called as the consistency index or the relative consistency. So which is actually giving a behavior of resistance towards the soil. So this IC will be equal to the liquid limit minus water content by IP. So when you add this IC and IL, that is the liquidity index, means you will be getting 1, because the WL minus W plus W minus WP you will be getting. So automatically the liquid limit minus plastic limit will be becoming as IP. So IP by IP will be equal to 1. And the fourth index is the toughness index, so which is actually determining the strength of the soil. So here IT is equal to IP by IF, where IF is the flow index, which we have seen in the liquid limit studies. So in there we will be doing Casagrande apparatus test, and you will be plotting a graph, and from that you will be taking a slope to find the IF. So that value is the IF value here. So when this IT is less than 1, means the soil is crushed at its plastic limit only, and for clay it is normally for 0 to 3 value, and it indicates the shear strength of the soil. And if the IF is more, then the shear strength will be decreasing. So the IF is more means which is in a denominator of that formula, so that the IT will be automatically reduced. So if IF is more, then IT will be more, that is the flow index is more, the toughness index will be reduced. So it means that the IT is directly proportional to the shear strength, and the IF is inversely proportional to the shear strength. And the next is the shrinkage index, which is denoted as IS, which is equal to plastic limit minus shrinkage limit. So it indicates the maximum presence of the clay fraction. And the next one is the activity number, which is denoted as A, which is equal to IP by C, plasticity index by C. C is nothing but the percentage finer than 2 micron of a soil. So this activity number actually denotes the water holding capacity of the soil. So if the value of this A is more, means it means that the water holding capacity of the soil is more. So here also the range is given. If A is less than 0.75, it is an inactive soil. If it is 0.75 to 1.25, it is a normal soil. And if it is greater than 1.25, it is a very active soil. So examples are montmorillonite and black cotton. So here this montmorillonite we have already seen, it is more in bentonite soil. So this bentonite will be actually having a activity number greater than 4. And the next one is the degree of shrinkage. So this also we have seen already. So here also the range is given for this value. With that we can find the type of the soil. So if the degree of shrinkage is less than 5%, it is a good quality soil. If it is 5 to 10, medium quality soil, 10 to 15, poor quality soil, and greater than 15, it is very poor quality soil. So the degree of shrinkage should not be very more for a soil.
Thank you, and keep watching for the next lecture on soil classification.